we are going to take a peek at this first quiz preview. Quiz isn't incredibly long. It's just there's lots of little detail stuff we're going to be taking a peek at. All right. State whether the functions represent growth or decay. Then give the y-intercept and the end behavior. Okay. So we got all this stuff, and I figure we'll do the end behavior right below here. So before I ever do anything with this first one, I should be able to get these first two parts. At least I should. Number one, should that be growth or decay? Okay, it should be growth because this value, even though it's a fraction, is greater than 1. It's actually like 2.5 if you'd plug it in. What should my y-intercept be? 0, 3. Because again, my a value directly correlates to what that's going to be unless there's a shift. Now, could I get this off the calculator? Sure. Do I need to get it off the calculator? Not really. Now, for the rest of these, I may need a little help. Well, domain, I shouldn't need help, but for the rest of them, maybe. So we'll take a peek. Again, make sure anytime you do a fraction, you get it in parentheses. We'll take a peek just to make sure things are going well here. Okay, growth, yep, okay. So I look at my picture. What's my domain going to be? Negative infinity to infinity, because it always is. My x values are always going to keep going. Even though they're coming along here, they're going to keep going forever to the left. And I can see as they're going here forever up. Okay, or forever to the right in this case. Range. Y values, bottom to top. Right. My lowest value that I approach down here is 0. It's not negative infinity. If I need to double check, I can look at the values in the chart and notice they're getting really, really close to 0, and then those e's are getting really, really closer yet to 0. And I was talking with some of you over the past couple of the days. There's a direct relationship, and you'll see it in a minute, between your end behavior and your range. But we'll talk about that. But always bottom to top. Even if it was flipped under, I got to watch for that. Now my end behavior, remember, I'm always going to have one of my x's that's going to infinity, or to the right, and I'm always going to have an f of x where x is approaching negative infinity, or heading to the left. And if you physically need to write down right and left with these to remind yourself of what you're looking at, I'd do that. So when I'm looking at this, I go, okay, so as my graph is heading to the right, what's my y value approaching? As I go to the right, it is positive infinity. As I go to the right, it keeps going up. But as I head towards negative infinity for x, as I head to the left, now we're approaching 0. Your range values and these guys are always going to be related to each other. You're always going to use the same two values in each. The order might change, but that'd be about it. Okay? Now, of course, I'm going to try to throw in some stuff to mess with you. Number 2, growth or decay? Oh. Let's see here. Now, if I just look at the 1/2, I would. I'd think decay. For those of you that said growth, why do you think it's growth?
4.
Nope. Yeah. That negative x is what's causing the difference here. Because remember, that negative is causing this value to act like it's a reciprocal. Because when I go to graph it, like, oh, basically this is turning this into that. It's taking the reciprocal of what's inside here and taking it like it's to the positive x. Because when I look at this, let me get this back down to where we normally would look, I notice a few things. Okay, we now see that it's growth. My y-intercept, just like before, directly related to my a value. Again, it's a point. Don't just write 4, because then we're talking about a line, and that's different. My domain doesn't change. Let's see here. Does my range change at all from the last one? Did I have any up or down shifts? No, we're still coming down and we're still hugging where y equals 0. And if I want to look at the chart to double check, again, as it gets more negative, it gets close to 0, but it's not going into the negatives. Those are the types of things you don't have a choice. You have to practice, you have to remember. And if you're still kind of playing back a couple of assignments ago, this could end up getting a little bit tricky. Now, oops, I got rid of my graph and I don't want to yet. My end behavior, and I'm in agreement, because this looks very similar to what we were doing on the last one. As x goes to the right, I notice my graph is going up towards positive infinity. As my graph is going to the left, approaching negative infinity for x, we're not approaching negative infinity for y, we're approaching 0. Range in my f of x's, direct relationship, okay? It's something that's a little trick that might be helpful. Now you get off a little easier on the next couple here. Graph and just do domain and range. Don't have to do the other stuff. So we can keep this as simple as go to the calculator. Again, just be careful when you're typing. Notice my minus 2 isn't part of the exponent, so I'm not putting it in the parentheses. So when I graph this guy, I'm like, this is sensible. We'll get there. Yep, the E is coming. So here, I notice a couple of things. I'm like, okay, it looks like it shifted down a little bit. I want to be accurate with my graph, so don't get careless here and just go with, I'll just put anything down. No, think about it a little bit. Try to get yourself at least 4 or 5 points that are somewhat accurate. I know with decimals it's not going to be perfect. I get it. But we want to graph enough, oops, that's better, that we start to see what value are we heading towards, but not going to be passing. Where's that line that we're not going to cross? And it looks like that value's -2. Well, I should know that already. My graph shifted down 2, which means my range is going to shift down 2. Any up or down shift is going to change my range. Nothing's changing my domain. I can shift this graph left, right, up, down. Doesn't matter. It's forever going to the left. It's forever going to the right. My range, though, typically will be 0 to infinity like it was in the first two, except here it's not. Here, the bottom of my graph starts at -2 and goes to infinity. Not negative infinity, because again, it's y values we're looking at, not the fact that you're going to the left. So you got to be careful on little things like that. We're always going bottom to top. But the only time that range will change, again, is when there's an up or a down shift. So then I look at this next one. Here's the key. And I'm even going to draw it in on mine. Anytime there's an exponent where you've got a plus or a minus, you've got to remember the parentheses, because if you forget, and I just put -4, sort of like I did on number 3, it's going to shift my graph down 4, and that's not what this is. Okay, that's a right shift. Because when I go to graph it, notice it moved to the right. Okay, instead of being over here and going up, now it's over here somewhere. So I can visually see what the shift is. And I know we normally do -3 to 3, but look at how little all those numbers are. That's not going to get me very far. So maybe I'll start out here a little further. But I do notice with all of those little itty bitty tiny numbers that I'm working with, it's real easy to see what value we're going to approach when I'm trying to figure out the other part of my range. Because again, if I'm not sure, just start looking. You're like, yep, oh, there's the e's. I'm getting close to 0. Okay. And play with it a little if you need to. Easiest question, easiest several points you'll see on this whole quiz are domains everywhere because they're never any different. If you miss domain, you haven't been paying attention for 3 days. And then my range, since my shift isn't up or down, this shift would be right 4. My range doesn't move from the 0 to infinity. So you'll notice on a lot of these, except for getting your graph, all the other information you should just be able to take straight from the equation. It really shouldn't take, a lot of the other stuff to get there. She's still stuck with me on the E. Are you on it? Are you further here, I'm assuming?
No, I'm on 4.
You're on 4. What E are you speaking of?
There's E's after a whole nine numbers.
You mean up here? Those?
Oh, yeah. Do I just go down?
Well, right, and you want to come closer to 0, but remember, those E's are just ways of saying we're really getting close to 0. Okay, I thought you were talking about a different E. I thought you were talking about the value E for a minute.
No.
Yeah, those E's just mean we're getting closer and closer to 0. So if you're seeing those in a lot of places, just keep scrolling until you start getting back into normal number land. But that's basically what we're going to be looking at with the graphs. Transformations, shifts. I'm going to use the word transformation, though. I'm warning you. If f of x is 7 to the x, that's my base, and g of x is this, explain how to obtain g of x from f of x. What is the transformation? What are the shifts? But I'm using the word transformation tomorrow. What are my two shifts, my transformations, going from here to here? I heard the up 2 part. I missed the first part. Okay. Because again, whatever's in the exponent is right or left. It's the opposite of what you would think because it's x minus h. This is always my up or down, and we just go with whatever the sign is. Positive is up, negative is down. But all those shifts are back in your notes from that first day we were doing it in 8-1. Then we get into the stuff we've been pounding for 2 days. The amount of radioactive isotopes decreases, decay, 4.5% per year. If a sample originated with 245 grams, determine how many grams the isotope remained for 15 years. I'm going to give you a general version of the formula. Okay, so you're not even going to have to figure out which one to use. So, I start with 245, my original amount. Am I going to be using plus or minus the percent? Minus, because we're decreasing. Do I just put 4.5 here? Yes. Do not put 4.5 or this will get really bad in a hurry. And then you can use t, you can use x, whatever it happens to be. So now to find my amount, I can do one of two things. I could just type this into the calculator and hit 15. And actually, in this case, that might be faster. Some of you I know like going to the y equals, and you can. But if you're being asked for one specific value, I personally think it's easier to just do that. And normally here, we're just going to round to the nearest whole number. If you wrote 122.8, I'm not going to mark it wrong. Now, some of you are like, but I don't want to go back and forth. I just want to keep doing y equals. Okay, we could. You would do the exact same thing, except instead of typing in the value for the exponent, you just use x. Once I typed that in, I could go ahead and go to the chart and just scroll down to 15. get the same answer. Again, if I was rounding off, I'd go to 123. So either one works. Whatever you're more comfortable with is absolutely acceptable. I just like to let you see what your options are going to be. But again, the formula will be there, so do not panic on something like that. Same idea here. Growth and decay formula. So we currently, or we're starting with 45,600. Am I going to be plussing or minusing the percentage? Plus grows 1 plus 0.023. Write an equation to represent the city's population. Done. Then calculate how many years will pass before the population reaches 60,000. Now, I could play guess and check. I don't want to do that, though. So what I would suggest, back to y equals, just type this in. And again, I'm going to be general this time because I'm going to start working my way down the chart until my y value equals 60,000. So once I get it typed in, I'm going to go to the chart. Okay, I'll come back up here to start like we did before. And I start scrolling down until I see the year where it breaks 60,000. Some of you have been asking me still about, well, how do I write this? You know, do I say, I would say year 13. Now, some of you put between 12 and 13. That's fine. I don't care. But the idea is it has to be to that value. I can't say, well, 59,906 if I round at 60,000. I'm going to put 12. Round up or put the 2 years it would fall between. I don't care which. Okay, either one of those, perfectly acceptable. So that's how that one would work. Now, 8 is where life gets a little bit interesting. She's like, wait a minute, that looks new to me. And it is, but it's going to work the same way the others have. That's why I'm not too concerned with this. We're going to invest some of our income in an account that collects 4% interest continuously. Sounds awesome. That's even better than daily. How long will it take for the account balance to triple? Use your calculator's table function. Now, I normally get asked 2 questions on this. They're like, well, wait a minute. They didn't tell me how much I started with. So how am I supposed to figure out when it triples? You get to make something up. So for instance, we'll just agree for this particular one, we're going to start with $1,000. When they talk about waiting until my account balance triples, if I start with 1,000, how much is triple that? 3,000. Okay. So here's how I would do this. I would say, okay, my principal, which again, you can use any number in here you want, but I'm just using 1,000. E is a value, we'll talk about that in a minute, times my rate, which again has to stay as a decimal. And since the question is how long, I don't know how long. Okay? This is what I'm going to type in the calculator. Now, the one thing we're going to have to talk about here is how do I get E? Because that's new. Okay, E is figured out by hitting second and ln. Okay, so to get E, I hit second and I hit ln, right down the left-hand side there. And that gives me E, and look at that, even better. It puts it into exponent form for me. How cool is that? So, all I've got to do now is type in the 0.04 and the x, since I can't use t. And what I'm going to be attempting to do here, once I get it into table mode, is scroll down until I get to 3,000. So my equation actually, I'd want to put the 3,000 in here. Now, if you put y equals, I'm not going to count it wrong. But by putting the 3,000 here, that reminds me, oh, this is where y normally is. I need to go until the y value hits 3,000. So it's going to take about 28 years for that balance to triple. So notice, I'm pushing on you. You come up with your own principle. You understand what tripling means. I'm going to start pushing some things like that. It's not just going to be cookie cutter, ooh, it's exactly like it is on every single question. I want you to think a little bit.
Wait, so you made up that number?
Yes, because they didn't tell me what the initial income is. I could have put 100, I could have put 10,000, I could have put whatever I wanted, as long as I knew, like if I'd have put 100 here, I'd have been looking to see when it got to 300. Or if I put 10,000 when it gets to 30,000. So you get some flexibility there, but I just like using normal kind of whole type numbers like that to make it work a little bit easier for me. But I'd get the same answer even if I'd have put 10,000 and going to 30,000. It would work the same way. But again, all the formulas are going to be there for you. So all you got to do is plug and chug on this stuff. As long as you can plug and chug, we're all right. 9. Short quiz. Notice 10 questions. Suppose you invest $1,200 in an account. Okay, that's my P. Paying 5% interest. Okay. 0.05. Compounded monthly. That's the one thing I'm not going to give you. If it's compounded monthly, what's my N value going to be? 12, because it happens 12 times a year. We get a month. That's my N. It's the same N I'm using up here. So 12 times T? 9. Same as before. If I want to stay general and use the chart, I can. But again, when they give me all of those values, when they tell me how long it is, I don't really get the point of trying to figure any of the rest of this out. All right, thank you. So, what we're going to do, clear this out, and just type what you see. Do not put extra sets of parentheses in here trying to get cute. The calculator will know to divide here first and then add it, so I don't need to put it in there. And then for my exponent, I could either multiply it out in advance, or if I don't, I do need to put that into parentheses. And then I'll go ahead and I'll hit enter, and I will have my account balance. Now here, since we're talking about money, I'll probably go ahead and go to the nearest cent. So like 22 cents. But again, I'll know if you put things incorrectly, because if you put some goofy thing like $27,000, I'm going to write on your quiz something like, ooh, let me know what bank you're working at, and I'll put my money there. Something like that to try and be a little bit, funny with the situation. But that's all I'm going to do with that. And then 10 is going to be the one that freaks some of you out. There's lots of lines here. Oh crap, and there's no numbers. If given the option of 2 investments, describe how to tell which investment accrues more money, which one makes more money. You can use graphical representations, examples, table representations, or function properties. Okay, let me put this in English for some of you. You're going to need to make up an example where 2 different things are going on, and then use that to explain how I figure out what's the better deal. So for instance, I'll just make something up here. Let's say I have $5,000. I'm going to invest that at 5% compounded, let's see, annually for 10 years. And again, you could use weekly, daily, whatever, okay? On my other half, I'm going to compare it, same amount, because I don't want to make it a different amount because that'd be kind of silly, at 5%, same percent, Because we know if it was a higher percent, we'd like that better. That's not going to take any thought. Here we'll do it daily. Because, man, it seems like I'm going to make a lot more money if if I'm doing it annually or daily. But again, make it any way you want to. Make it simple interest if you want to, even though we didn't talk about it as much. All you would have to do to explain this is say, okay, I got the equation right here. I'm going to go ahead and I'm just going to say, here's what my calculation is. Mr. H, I'm showing you that I understand my n values and I understand where all of these things go. So here's the situation. Here's how I calculated it. And then all you're basically going to have to do after this, oops, no, Harty, is come up with the numbers so you can see, so you can prove why that is. Is it really that much better if it's compounding more often, or am I just kind of full of it? What's the deal here? So I look and I'm like, okay, I gotta type this in. Oops. And I'm going to see, does it really make a difference, or is it something that's just kind of a myth? And I know, we've talked about this some, but I'm starting to prepare you for some of the things we're going to start seeing where I'm going to look more for an explanation, where I can start to see that you understand the concept that we're doing here, and that you're not just, for lack of a better word, regurgitating what I write and not really thinking about it at all. Because that doesn't help anything. Now, am I going to be able to retire off the amount of difference? No. But I prove this way that it's better. I make more money when it compounds more often. And that's where you're actually proving it, instead of just saying, well, compounds more often, that's good. Why? Show me. So just come up with an example where I can see what's going on and work it. Now tomorrow, I may give you the exact same question. I may give you a specific situation where I want you to tell me which deal is better and why. I'm not sure. It could be either. But the idea is that you're going to have to think a little bit with this. So you may have to go back and kind of look a little bit, review a few things, maybe review some of those papers, or maybe if you're still working on some of those packets, it'll kind of help reinforce this for you now that you've seen it some more. Because basically we did one of each type of problem here. But now, here's the deal